Hi everybody, this is Mr. Short. Today we're going to talk about homeostasis. On the next slide we'll define homeostasis. We'll also explain its importance. In a couple slides we're going to talk about what are called negative and positive feedback loops. We'll talk about their roles in maintaining homeostasis in the human body. Here's our definition of homeostasis. It's the maintenance of relatively stable conditions in the body's internal environment. So, even when external conditions change, the body's internal conditions stays within a tight, narrow range. The example that we'll go to on the next slide has to do with temperature, body temperature. I want you to note that all body systems contribute towards the maintenance of homeostasis. And finally, if the body's internal conditions change greatly, note that we call that illness. Illness can result. Okay. Here's an example of negative feedback loop. So first of all, a definition of negative feedback is a mechanism that brings a change back to its normal set point. So set point just means where it normally is. In terms of body temperature, the set point for human body temperature is about 98.6 degrees Fahrenheit. So as long as it's about a degree plus or minus 98.6, within that tight range, we're fine. But we have to ask the question, what happens when the body temperature goes above normal or below normal? All right, so starting out at this set point of 98.6 degrees Fahrenheit, if body temperature rises above normal, the nervous system tells your skin, dermal means skin, so the nervous system tells your skin blood vessels to dilate, that means to expand, and sweat glands to secrete sweat. Those have the effect of loss of body heat to the surrounding environment. That has the effect of body temperature dropping back towards normal, back to 98.6, which is the set point. So see how in this top example, the body temperature became too high, the body did something to lose body heat, bringing the body temperature back towards this set point of 98.6. Now what we'll do is we'll take a look at the bottom example. In this example, body temperature drops below normal, below the set point of 98.6 degrees. In this example, the nervous system also acts on the skin's blood vessels, but in this case, it causes them to constrict. To constrict means to shrink in diameter. It also causes the sweat glands to remain inactive, and in this case, it has the effect of conserving body heat. So instead of giving away body heat to the surrounding environment, body heat is conserved, and because body heat is conserved, body temperature rises back towards normal, which again is 98.6. Let's take a look at this lower route also. You can see following the lower route in the pink box, it says body temperature drops below normal, causing the nervous system to act to constrict the skin's blood vessels. And then with the arrow down, it says, also, if body temperature continues to drop, the nervous system signals muscles to contract involuntarily. That's shivering. Muscle activity then generates body heat, and the generation of body heat has the effect of raising the body's temperature back towards its normal set point of 98.6 degrees Fahrenheit. Okay, so we have two examples here of negative feedback, both of which have to do with maintaining this set point body temperature of about 98.6 degrees Fahrenheit. So when you think about negative feedback, think, okay, something has taken it outside of the set point or away from the set point, and this brings it back to that norm, back to the middle. That's very different than the next example, which has to do with what's called positive feedback. Positive feedback is this: mechanisms that bring about even greater change in the same direction. So do you see how with negative feedback, it brought a change back in the opposite direction, but with positive feedback, it's change in the same direction. The example we're going to take a look at is the birth of this baby that's right here. So note that we have the cervix right down here. We have the cervix and the birth canal. All right, so let's take a look at this example. Point number one, the head of the fetus pushes against the cervix. Point number two, nerve impulses are transmitted from the cervix to the brain. Point number three, the brain then stimulates what's called the pituitary gland to secrete a hormone called oxytocin. Remember, hormones float through our bloodstream and they act on distant sites. So this hormone, oxytocin, is going to float through the bloodstream. The oxytocin is carried through the bloodstream to the uterus. This is the uterus. Oops. The oxytocin is then going to stimulate uterine contraction and push the fetus even further through the cervix. So see how the initiating event was the head pushing on the cervix, and that had the effect of secreting oxytocin, which stimulates contractions of the uterus, pushing the baby even further out of the uterus. So let's go back to the definition and make sure that we understand. Remember, positive feedback is a mechanism that brings about an even greater change in the same direction. Head pushes on cervix, oxytocin causes the uterus to contract, causing the baby to come even further out of the cervix. And it becomes this cycle that keeps fueling itself in this case. Okay, so again, we've taken a look at two different types of homeostatic mechanisms. One is called negative feedback, which is on this. Negative feedback brings it back towards the set point. One is called positive feedback. Positive feedback takes it in even farther away from that set point. All right, thanks a lot, guys. Have a great day.